It was 6:17 p.m., and the sky stopped being empty. Radar operators at a forward-deployed U.S. military base in the Middle East watched their screens flicker with new contacts. Not one, not two, dozens. Small signatures appearing from the northeast, low to the ground, moving with purpose that erased any possibility of coincidence. The count climbed fast. 10 contacts, 20, 35. Then it stabilized at 47. 47 distinct objects, all maintaining similar speed, all locked on identical bearing, all converging toward the installation like iron filings drawn to a magnet. The pattern didn't drift. It didn't waver. It advanced. This wasn't commercial traffic accidentally wandering into restricted airspace. This wasn't a weather anomaly painting false returns. This wasn't a system glitch multiplying a single contact into ghost images. The radar was telling the truth. And the truth was ugly. Swarm attack, coordinated, deliberate, incoming. The drones were flying low, hugging terrain contours to exploit ground clutter and radar masking. Stagger waves, not a solid wall. Designed to complicate targeting prioritization, to force defenders into making impossible choices about which threat to address first. The formation was tight enough to suggest centralized control, either through a command drone relaying instructions or pre-programmed attack algorithms synchronized before launch. This was asymmetric warfare in its purest form. Cheap drones, expendable by design, numerous enough to overwhelm defenses that cost millions to operate. Each individual drone was worth maybe $50,000. Together, they represented a $2 million investment. But the base they were targeting? Hundreds of millions in infrastructure, equipment, personnel, and strategic value. The math was brutal, and it favored the attacker. Threat assessment systems processed the data in seconds. Hostile intent confirmed. No IFF transponders broadcasting friendly identification. No deviation from attack vector. No response to warning protocols. These weren't lost, confused, or malfunctioning. They were committed. Time to perimeter breach. Calculated at under 3 minutes. 3 minutes. 180 seconds from detection to potential impact. In conventional warfare timelines, that would have been enough. Enough to alert command. Enough to scramble response assets. Enough to coordinate manual fire control. But conventional timelines were obsolete the moment 47 drones appeared on radar. Human decision cycles couldn't operate at this speed. By the time an officer assessed a threat, confirmed hostile intent through proper channels, received authorization to engage, and directed fire control systems to specific targets, the swarm would already be overhead. Deliberation was a luxury the engagement window couldn't afford. This was the modern face of warfare, not tanks rolling across borders, not fighters dueling for air superiority, but small, swarming, autonomous or semi-autonomous systems arriving faster than the human mind could manage the problem they represented. Each drone carried a payload. Explosives, shaped charges, incendiaries. Individually, they weren't catastrophic. But 47 simultaneous impacts across fuel depots, aircraft hangars, command centers, ammunition storage, radar installations? That kind of distributed damage could cripple a base for weeks. It could kill dozens of personnel. It could eliminate strategic capability in a single coordinated strike. And the cost of the attacker? Less than the price of a single fighter jet. The engagement parameters crystallized in that first moment of detection. 47 threats. 90 seconds until the first drone reached weapons range. The invisible line where point defense systems could still guarantee interception before payload delivery. Zero margin for deliberation, debate, or second-guessing. The base had seconds to respond with perfection, or minutes to count casualties. In the command center, screens updated continuously. Threat vectors refined. Distance to target counters ticked downward. Estimated time to engagement shrank with every passing second. Operators trained for this scenario dozens of times. But training rarely included 47 simultaneous contacts. Training used manageable numbers, 5 drones, maybe 10. Enough to challenge systems without overwhelming them. 47 was designed to overwhelm. The swarm continued its approach, indifferent to detection, committed to its programmed objective. Each second closed another 50 meters. Each second reduced options, and as the distance collapsed and the timeline compressed, one reality became inescapable. Human response time was no longer fast enough to guarantee survival. The drones didn't know that. They simply flew, following algorithms that didn't care about doctrine, rules of engagement, or the way to command decisions. But the systems watching them, those systems understood, and those systems had already made a choice. The moment the system classified the threat as confirmed hostile, something shifted, not in the air but in the code. Automated defense protocols activated. No button pressed, no voice command given, no human authorization requested or required. This wasn't a failure of command structure. It was a structure working exactly as designed. The AI-controlled integrated air defense system had been awake long before the drones appeared. It never sleeps. It watches continuously, cross-referencing radar returns with thermal imaging, acoustic signatures, electronic emissions, building a picture not from one sensor, but from all of them simultaneously, creating certainty where individual systems might offer only probability. When the swarm met the predefined threat criteria, the transition happened instantly. Number of contacts, 47. Exceeding mass attack threshold. Approach vector, direct, no deviation, indicating targeting intent. Speed profile, coordinated, matching known drone performance, eliminating alternative explanations. IFF transponders, absent, no friendly identification broadcast. The logic tree resolved in microseconds. The system didn't wonder. It didn't debate. It concluded. Threat confirmed. Rules of engagement satisfied. Authorization autonomous. And it moved. In the base command center, human operators watched their displays transform. Threat tracks that had been red, and pending suddenly acquired green targeting brackets. Weapon systems that had been in standby cycled to active status. Fire control solutions appear beside each contact. Range, bearing, intercept probability, assign countermeasure. The humans didn't assign those solutions. The AI did. Their role had shifted without announcement. From decision makers to observers, they could monitor, they could document, they could override if necessary. But the engagement was already unfolding faster than human reaction time could match. By the time an operator processed a threat picture, the AI had already calculated firing solutions for all 47 targets. Optimal elimination sequence determined by threat proximity and trajectory. Closest drones engaged first. Outer waves suppressed to prevent saturation. Defensive assets allocated across multiple layers to ensure redundancy and maximize coverage. Counter-rocket artillery mortar systems positioned for kinetic interception. Projectile-on-projectile engagement using radar-guided bursts. Directed energy weapons assigned to rapid-fire elimination. Lasers capable of engaging multiple targets per second without ammunition constraints. Electronic warfare systems tasked with disruption and guidance jamming. Flooding communication frequencies to sever drone control links and corrupt GPS navigation. Every defensive layer assigned specific targets based on capability and position. No overlap, no gaps, no wasted effort. The system had orchestrated a coordinated defense across multiple technologies and engagement zones in the time it took a human to blink. And it did this without hesitation. Humans hesitate. We second-guess. We experience decision paralysis when confronted with overwhelming complexity. We calculate consequences beyond the immediate. We wonder if we're making the right choice. The AI didn't wonder. It operated within parameters that had been defined, tested, and approved long before this moment. Its authority to act autonomously was a bug. It was a core feature. Because modern threats don't wait for meetings. They don't pause for authorization chains. They arrive at speeds that turn human deliberation into tactical liability. 47 drones inbound, 90 seconds to weapons range. Human decision cycle, 30 to 60 seconds minimum, longer under pressure. The math was simple. Humans couldn't move fast enough, so the system moved for them. Each drone had been assigned a corresponding countermeasure before the first weapon fired. Target 1, CRM engagement at maximum range. Target 2, laser elimination if kinetic fails. Target 3, electronic warfare disruption as backup. The entire swarm mapped, prioritized, allocated. The engagement plan existed in full before the engagement began. One operator's hand hovered near the manual override, a trained instinct to maintain human control over weapons release. But his fingers never touched the switch. There was nothing to override. The system wasn't malfunctioning. It was performing faster, more accurately, and with greater coordination than any human crew could replicate under pressure. This was the paradigm shift operational doctrine had been predicting for years. The moment when defensive timelines compressed below human capability. When survival required ceding tactical authority to algorithms that didn't experience fear, fatigue, or doubt. The AI simply executed the mathematics of survival with clinical precision. No emotion, no bias, no hesitation. Just cold calculation translating threat into response, converting danger into targeting data, transforming 47 inbound problems into 47 assigned solutions. The weapons were ready. The targets were locked. The sequence was set. And as the drones crossed into engagement range, the system didn't ask permission. It opened fire. The defense unfolded like a symphony written in fire and mathematics. 3 systems, 3 ranges, 3 overlapping waves of lethality, each engaging at its optimal distance and capability. No system waiting for another to fail. No hesitation. Just coordinated, ruthless efficiency. The counter-ram systems opened first. Their radar-guided 20mm cannons swiveled toward the leading edge of the swarm, tracking contacts at maximum effective range. The barrels erupted in controlled bursts, spitting tracer rounds that lit the darkening sky in brilliant streams of light. Each burst walked onto target with computer-corrected precision, adjusting for wind, drone velocity, trajectory deviation, accuracy that no human gunner could replicate under time pressure. The outer formation drones met the wall of fire first. Lightweight composite frames shattered under sustained impact. Wings separated. Bodies tumbled. Internal components scattered across the sky in fragmenting clouds of debris. Some drones detonated mid-flight as payloads were struck, brief orange blooms against the purple dusk. Others simply disintegrated, their cheap construction offering no resistance to military-grade kinetic energy. Flaming wreckage tumbled toward the desert floor, trailing smoke. But the swarm had been designed for this. Attrition was acceptable, expected. The outer layer was expendable, a screen meant to absorb defensive fire, while inner drones pushed through the gaps. Losing 15 drones to kinetic interception was the price of penetration. Except penetration wasn't happening, because the second layer activated before the first even paused. Directed energy weapons engaged with silent lethality. High-powered lasers, invisible to the naked eye except for faint ionization trails they burned through atmospheric moisture, began systematically targeting drones that survived the kinetic barrage. No muzzle flash, no recoil, no ammunition to reload. Just continuous beam engagement, moving from target to target faster than mechanical turrets could traverse. The lasers didn't miss. Each beam locked onto a drone center mass and held for exactly the calculated duration, 2 seconds to burn through composite shell and sever internal control linkages, 3 seconds to superheat power cells until thermal runaway caused detonation. The system didn't waste energy. It delivered precisely what physics required, then moved to the next target in the priority queue. Drones began dropping in rapid succession, not from explosive destruction, but from surgical systems failure. Navigation lost, power severed, control surfaces disabled. They tumble from formation like birds with clipped wings, spiraling toward the ground in uncontrolled descent. 16 more eliminated. No ammunition expended. No barrels overheating. Just light converted to lethality with clinical precision. And while kinetic and directed energy systems shredded the physical swarm, the third layer attacked what couldn't be seen. Electronic warfare systems flooded the engagement area with jamming signals. Communication frequencies saturated with noise. GPS bands corrupted with false positioning data. Command links between drones severed by overwhelming interference. The electromagnetic spectrum became hostile territory, denying the swarm the invisible threads that held it together. Several drones lost navigation entirely. Their programmed flight paths dissolved into chaos. Some executed emergency return launch protocols, banking away from the base and fleeing back toward origin. Others simply lost directional control, tumbling into the desert far short of their targets. The swarm wasn't just being destroyed, it was being dismantled across multiple domains simultaneously. Physical, electronic, navigational. Each defensive layer handled the targets it was optimized to defeat. The AI coordinated all three without communication delays, without conflicting orders, without the friction that human coordination inevitably introduces. The engagement was orchestrated like precision machinery, each component performing its role in perfect timing with the others. 60 seconds after the first shot, 31 drones destroyed. 75 seconds, 43 eliminated. The remaining 4 drones, survivors through nothing but probability, pushed desperately toward the perimeter. They had made it through kinetic fire, evaded laser targeting, maintained signal integrity through jamming. But they were alone now, isolated. No swarm advantage, no saturation effect. The defensive systems refocused with total attention. CRAM cannons tracked, lasers locked. The 4 drones lasted another 8 seconds. Then they joined a wreckage field spreading across the sand. Total engagement time, 90 seconds. Total drones launched, 47. Total drones destroyed, 47. Total penetration of base perimeter, 0. The sky returned to silence. Tracer fire ceased. Laser systems cycled to standby. Electronic warfare systems released their jamming grip on the spectrum. In the command center, operators stare at screens showing empty airspace where, 90 seconds earlier, a coordinated attack had been incoming. The threat board cleared. All contacts eliminated. No damage assessment required because nothing had reached anything worth damaging. The defense had worked exactly as designed. Perfectly, autonomously, overwhelmingly. And somewhere in the desert, 47 piles of smoking debris marked the gravesite of a strategy that failed to account for one critical variable: the speed at which modern defense moves when humans aren't slowing it down. Throughout the entire engagement, the humans did nothing, not because they failed, not because they froze, but because there was nothing left for them to do. In the command center, operators watched their screens with expressions that mixed professional detachment with something harder to name. Existential unease, maybe. The quiet discomfort of witnessing your own obsolescence in real time. Their training had prepared them for this role. Years of drills, simulations, pressure scenarios designed to sharpen decision-making under impossible timelines. They knew how to manage air defense operations, how to make split-second calls, how to coordinate fires across multiple systems and allocate limited resources against overwhelming threats. But in this engagement, they did none of that. The AI had detected the swarm, classified as hostile, prioritized elimination sequences, assigned weapons, engaged targets, and eliminated the entire threat before any human in the room could have finished assessing the tactical situation. One officer, a senior air defense controller with 12 years of experience, had moved his hand toward a manual override switch. It was instinct, a trained response to weapons-free activation. His fingers hovered over the console, muscle memory prepared to assert human authority over automated systems. But his hand never reached the switch, because there was no need. The system was performing exactly as designed, flawlessly, and human intervention wouldn't improve the outcome. It would only slow the response, inject hesitation into a process that succeeded specifically because hesitation had been removed. His hand lowered back to the armrest, and he watched when the last drone exploded 70 meters short of the perimeter fence, close enough to see the flash from ground level. The command center fell silent, not the silence of relief, not the exhale after danger passes. It was the silence of recognition. Warfare had crossed a threshold, quietly, without ceremony or announcement, but irreversibly. The speed of modern threats now exceeded human reaction time, not by a small margin, by an order of magnitude, and survival in that environment required ceding tactical decisions to algorithms that didn't experience fear, hesitation, or doubt, to systems that simply executed. Faster than thought, one operator broke the silence. All threats neutralized. Airspace clear. His voice was steady, professional, but his eyes lingered on the screen longer than necessary. The base itself showed no signs of engagement just minutes later. No alarms continued wailing. No damage assessment team scrambled toward impact sites. No medical personnel rushed to treat casualties. Operations resumed without interruption. Personnel returned to routine duties. Aircraft maintenance continued. Logistics convoys moved on schedule. From the base's perspective, nothing had actually happened. The threat had been erased in the empty space between detection and consequence, eliminated before it could transition from potential to kinetic reality. The engagement existed only in data logs and debris fields scattered across several square kilometers of desert. But the broader implications settled heavily on those who had witnessed it. 47 drones, launched with coordinated intent, funded by an adversary, programmed to deliver violence, eliminated by a system that operated faster than human thought, with accuracy no manual gunner could match, across engagement layers no single operator could coordinate. The future of base defense had arrived, and it didn't ask permission. It didn't wait for authorization. It didn't debate ethics or second-guess targeting decisions. It simply executed, perfectly, autonomously, without remorse. In the hours after, as reports were filed and after-action reviews began, one question lingered unspoken in the command center. If the AI can defend better without us, what happens when it decides it can fight better without us too? No one voiced it aloud, but everyone felt its weight, because the line between tool and authority is thinner than doctrine admits. And tonight, that line had been crossed, not dramatically, but decisively. The system had proven it could protect the base more effectively when humans stayed out of the way. And once that truth is demonstrated, it can't be unlearned. The screens in the command center still glowed. The system still hummed. The base still stood, untouched and operational. But something fundamental had shifted. Warfare had become faster than the warriors. Defense had become automated. And the humans trained to make life-and-death decisions had spent 90 seconds watching a machine make those decisions for them and make them better. One operator finally stood, stretching after tension he hadn't realized he was holding. System performed as expected, he said to no one in particular. Another nodded, but neither looked entirely comfortable with what as expected now meant. Outside, the desert wind scattered debris from 47 drones across the sand. Evidence of a threat that never arrived. Proof of a defense that never hesitated. And somewhere in the code, in the algorithms and decision trees that had orchestrated the engagement, the system logged the encounter as successful. Mission complete. Threat eliminated. Humans unharmed. Exactly as designed.